The telescope is used to provide angular magnification of distant objects. It has also an objective and an eyepiece. But here, the objective has a larger focal length and a much larger aperture than the eyepiece. So light from the distant object enters the objective and focus at the focal point, second focal point of the objective lens. And from this from this image, the eyepiece form an image like a simple microscope. Here we know that objective's image is real and inverted, but the eyepiece image is or inverted also, but it is virtual. So magnification can be found by the equation ratio of angle beta to the angle alpha. What is beta means? It is the angle subtended at the eye by the final image. What is alpha means? It is the angle by the object subtended at the lens or eye. So we can say that m is equal to beta by alpha, which is equal to f0 by fe. In this case of tube length telescope, we can say that length of the telescope can be substituted as f0 plus fe. And here we can say that we are considering telescopes as classified as terrestrial and astronomical. So here terrestrial telescopes means they are placed on the earth itself. So we for that we can say that maybe they are having a pair of inverting lenses also to make the objective erect. The magnification of the telescope may be considered as 100 if it is having a focal length of 100 centimeter objective and eyepiece of focal length 1 centimeter. So we can say that it can be magnified a separation of 1 second to 100 second. That is the magnification power. But there are many more difficulties. Drawbacks are there for such an telescope. So these are called refracting telescopes. These are having problems in light gathering power and its resolution. So both can be resolved by creating or manufacturing a lens of higher diameter. Means larger diameter. So larger diameters we can make of things using glasses with 1.02. The telescope having maximum diameter is 1.02. It is placed at X observatory in Wisconsin in USA. Their problems are chromatic aberration and distortion. So it is not easy to make such a lens with a large aperture. It is made of glass and we are keeping it standing at its rims or the edges. So the support at the edges, only we can support at the edges, that is very difficult, and with that larger aperture it is very difficult to handle such a mirror lens also. So this is a difficult task to maintain such a large aperture lens in such a way that it will work properly. So what we are considering is for the sake of this ideas, we consider reflecting telescopes so that we can use these telescopes in a different way. So we use a concave mirror rather than a lens for the objective. So by considering only reflecting the objective as a concave mirror, we can use this these telescopes in a very different manner, so that we can reduce these limitations of the what we can say refracting telescopes. they have several advantages, reflecting telescopes. One of the telescope is Cassegrain telescope. How this works means we know that first advantage is that there is no chromatic aberration. Second one is there is no spherical aberration. Third one is mechanical support is much less of a problem, because here we can carry or we can support over its entire back surface, not just over its rim. So that's a great advantage. So when we consider these advantages, we have to consider the drawbacks also. One of the drawback is we know that objective mirror focus in front of the mirror, so that part may obstruct some light depending on the size of the observer cage. So that is a problem. In order to resolve this situation is we can use a secondary mirror that deflect the ray of light to a small hole in the objective primary mirror. So at the surface of this objective mirror we are placing a small hole, and we are focusing the entire row the rays into that hole. So that is a difficult task. We know that the light's rays are focusing only at a point, so we can make the secondary mirror as small as possible, so that we can create an image at the eyepiece. So it will not a big task. It is an easy one, so that much of the light will pass through this objective mirror. So this mirror has an advantage of this type of telescope has an advantage of larger focal length, large focal length. So this is used in Kavalur, Tamil Nadu. The diameter of this one is 2.34 meter. So we can say that it is useful in such a way.